today we are going to do, today we're going to put two lessons together. We're going to put lesson 10 and lesson 11 together. It's easy. We can totally do it. We're going to talk about volumes of cylinders again, and prisms, and oblique prisms. And I'll show you what that means. So if we look at page 583, we have two stacks of coins here. This image shows the same number of coins arranged in different ways. So how are they different from each other? One is vertical, A is vertical, and B, this is what we call oblique. It looks slanted. It would be the same cylinder as in the picture A, and it's just leaned over with the base still resting on the flat surface there. And the height may be a little bit different in this one because we don't use this height. Okay, that's called the slant height, and we don't use that to determine the volume. We use this height. So if this height were 25, then this height, and it makes a right angle, would also be 25. So the heights will be the same, and then the volume would still be the same. Just because it's leaned over like that, because our height right here is the same amount, then it's going to be the same. So let's look at the second one. The image shows two rectangular prisms. The base of the prisms are congruent. So if it was a rectangle, a 4x6 rectangle here, then this one would also be 4x6. Each base has an area capital B, that means area of the base, square units, and the prisms are the same height. A plane intersects the two prisms parallel to their bases, creating cross sections. Sketch the two cross sections. How do their base shapes area compare to each other? Well, it already said that they were the same areas. The bases of the prisms are congruent. So how do their shapes and areas compare to each other? The areas are the same. Shapes may be a little bit different because this would be a rectangle, but this one just may be a parallelogram that's not a rectangle. Kind of looks like that, doesn't make right angles. How would the shape or area of the cross sections change if we move them, move the plane up or down? It would be the same. These would stay the same, and these would stay the same, not the same to each other. And how do the volumes of the prisms compare? Your volumes are the same. So let's look at this. It says, for each pair of solids, decide whether the volumes of the two solids are equal. Explain your reasoning. Okay, so we're not going to do partners. You're watching this video, you're by yourself. So let's find the area of each thing. Remember, the area for a cylinder, volume for a cylinder or a prism is capital B times your height. For a cylinder, your capital B equals pi r squared. And for a parallelogram or a rectangle, your capital B equals base times height. And for a triangle, let's see, do we have a triangle here? We do. We have a triangle on this one, on number 4, and that would be, not area, capital B would be 1/2 base times height. So let's do a couple of these. So it says, how do they, are the two solids equal, the volumes equal? So let's look at this. Capital B here is 12. So we're going to go 12 times your height. So which is 12 times 6. And then, so that's 72 units cubed. And then this one is capital B is your base times your height. So we're going to go 4 times 3 times your height of the prism. So 4 times 3 is 12 times 6 is 72. And so on number 1, your volumes are the same. You're going to write that. Your volumes are the same. calculated those out. So let's look at this. We have a cylinder and we have an oblique cylinder. The first one's oblique, the second one's that. So on this one, we're going to use this height here, not this height. That's our slant height. It looks like we have the same circles on top and bottom of each one. They both have a radius of 3. So capital B is pi r squared. So we're going to go 3 squared, which is 9 pi. So that's capital B for both of them. And then on the first one, we have to do that. 7 height times 9 pi. So 7 times 9 is 63 pi units cubed. And for this one, it would be, your height is 10 on this one because it's not slanted. So 10 times 9 pi. So this one is 90 pi units cubed. So the volumes of those two is not the same. The reason, because the heights are different. Now, the slant height and the height of the second one are the same, but we're not using the slant height. We're using the height, the one that makes the right angle. So let's look at number 3 without even calculating. Look at it. Would these be the same? Okay, so we have the same base here. Okay, we have the radius is the same, 3, so that's going to be 9 pi. Now, this is a cone. We haven't learned how to find the volume of a cone yet, but is the height the same? So the height on this one is 5, and the height on this one is also 5. So without calculating number 3, yes, they are going to be the same. They have the same capital B, the same base, makes the same area of the base, and they have the same height. So I want you to look at number 4, 5, and 6. Do they have the same base? Do they have the same height? You may have to calculate on this. This is a triangular prism. So 1/2 capital B times H. This is your base and height. This is the other height of the whole prism. So just tell me, do you think they're the same? Why or why not? You may not have to calculate. Number 5, you definitely can't. Number 6, you can't. All right, so just the summary of this is if you have the same area of the base, capital B, and you have the same height, regardless if it's oblique or not, you are going to have the same volume. Let's go to this page is your next unit. It says calculate the height of each solid. Round your answers to the nearest tenth. Well, we don't know how to calculate this yet because I haven't shown you. So we're just going to calculate this one here. We don't have our height. We have our slant height, but we're not going to use that, okay? So we need to find this. This gives us a right angle, a right triangle. Here's my right triangle, okay? We know that this is 50 degrees. This is 12. We need to find x. So this is our hypotenuse. This is our opposite of 50 degrees. And we know that sine equals opposite over hypotenuse. So we're going to put this in the equation to find the opposite side. So sine of 50 equals my opposite over my hypotenuse. Because x is on the top, we're going to end up multiplying. So you'll put this in your calculator. So if we go 12 times, and then we hit the sine button and 50, and we get 9.19. So we're going to go x equals 9.2. Okay, but we said that we're going to find, that's all it wants, is to find the height. Okay, so we can come back and do A. I'm sorry about that. So x is 9.2. Here's our triangle. Okay. And we know that this is 17.3. We don't know this. Well, we're not going to use trig on this one because we don't know any other angle except our right angle. We can use this. Okay, and so x is going to be a or b squared. It doesn't matter. C is 17.3, and the other a or b is 6.5. So figure that out. Give me what my height is on that. Let's look at this. Here are several solids. Without doing any calculating, identify 2 solids you think would have the least difficult volume calculations and 2 solids that would have the most difficult volume calculations. Okay, so I want you to go through here and tell me which 2 you think would be the easiest, which 2 you think would be the most difficult, and why. Then it says choose 3 of the solids. At least 1 should be from your least difficult, 1 should be from your most difficult, and calculate the volumes of your solids. Remember, let's just think about this. It equals this in all of these. And so for the cylinders, this may help you if you write this out. B equals pi r squared, and then don't forget to multiply it by your height. For the prisms with a rectangle, like A and C, okay, it's B equals base times height, whatever makes that 90 degrees. And then for the triangles, so for D and F, capital B equals 1/2 base times height, and your base and height are the ones that make a right angle. Sometimes you may have to find the other right angle, the other base or height using your Pythagorean theorem that you used in the warm-up. So go ahead and do that. You tell me the 2 easiest, the 2 hardest, and why, and then pick 3 and find their volumes. Okay, we're moving to the purple pages of lesson 11. So the prism has a right triangle for a base. What is the volume of the prism? So remember, we have volume equals capital B times H, and in this case, capital B is the area of a right triangle or any triangle. So capital B equals 1/2 base times height. So if we look, here is our right triangle. Here's our base and height, 4 and whatever this is. We don't know what that one is. So we have to find that. And we have this other side of this triangle. So we can use a squared plus b squared equals c squared. So we're going to go 4 squared plus x squared equals 5 squared. Because a and b are legs. They're the ones that make this right angle. So this is 16 plus x squared equals 25. Subtract this. And then we're going to take our square root. So x equals 3. So in this case, our base and height is 4 and 3. So we go 1/2 times 4 times 3 times the height of this, which is 8. So go ahead and do this problem and answer that. An oblique cylinder with a base of a radius 2 units. So here we go. This is 2. As shown, the top of the cylinder can be obtained by translating the base by the directed line segment AB, which has this length. The segment AB forms a 45-degree angle, so here we go. This is 45 degrees with the plane of the base. What is the volume of the cylinder? So we have to find this. Here's my hypotenuse. Here's my opposite. That's using sine of 45 equals x over 6 square root of 2. So you're going to go 6 square root of 2 times the sine of 45. And whatever you get there is your height. So volume equals capital B times height, which would be pi times 2 squared times whatever your x is. Okay, I want you to finish number 2, do number 3. Go ahead and do number 6. Remember, this makes this one will actually make a cylinder with a hole in it, and your hole will be this part right here. So that would be 2. Okay, and that's it.